Solve the system of equation using Cramer's rule. If we go over to the right here, we have two equations, and they're going to be in the format of ax plus by equals to c, and dx plus ey is equal to f. So I'm going to type over this, or write over this, so that you can visualize the coefficients and what the values are. Okay, so we're going to do the determinant A, B, D, and E. So A would be, notice if this represents a 1 there, so that would be 1, 2, 4, and 5. Okay, we'll go ahead and do all, set up all three. It'd be dx, and we have dy. So dx, if I want x, notice if I put my hand over the x, I have my y and my constant, but it's in the order of CB, not BC, so that's something to take note of. So that matrix would be 3, 2, 6, 5. Okay, and then my dy, if I put my hand over the y, okay, if you would put your hand over the y, you see you only have the x and the constant left, but it's in the form of AC df. Okay, so let's write that down. Our A would be 1, our C is 3, D is 4, and F is 6. So we have our matrix. Now we're going to do this one manually instead of putting it in the calculator. The next problem is going to be a 3 by 3, and we will put that one in the calculator. So what the formula says is I need to cross, multiply, and then I'm going to subtract. So I want my main diagonal, which would be 1 times 5 minus 2 times 4. So that's 5 minus 8, which is a negative 3. So D is equal to a negative 3. I'm going to do the same thing for the next two for dx. So I have 3 times 5 minus 2 times 6. That'd be 15 minus 12, which would be 3. So dx would be 3. One more time. Always start with the main diagonal. Down, up, down. So 1 times 6 minus 3 times 4. 6 minus 12, which is a negative 6. Now what Cramer's rule says is take dx over d. So we know d is going to be a negative 3. And notice d is always in the denominator. dx is 3. So that's a minus 1 for x. And dy, It's a negative 6, so that's 2. So what have we done with Cramer's rule? What that means is, of those two lines, when we draw them, they will intersect at a negative 1, 2. Now we have a 3 by 3. One important thing before we get started is to notice that in this particular case, we do not have a y. So we would have to rewrite that and put a 0 for a placeholder. Okay, that's very important. So I'm going to go ahead and set the matrices up, and we're going to use the calculator. We're going to show you two different ways to use the calculator. So the first order is going to be, for D, is going to be arranged as A, B, C. So we're going to do those points, pairs, and DX is in the order of D, B, C. DY is A, D, C. And DZ is A, B, D. Okay, so let's go back and look at, remember this is AX plus BY plus CZ is equal to D. So ABC is going to be 1, negative 1, 3, 3, 0, 1, 1, 4, 1. Going to DX, I'm going to have my D's first, and you could just go ahead and write all your D's down. 2, 2, 18. My B's are going to be a negative 1, 0, and 4. C, 3, 1, 1. DY, ADC, we have all my A's, 1, 3, 1, D, 2, 2, 18, and C, 3, 1, 1. And our last one, DZ, would be A, which is 1, 3, 1, B, a negative 1, 0, 4, and D, 2, 2, 18. So this is the first thing you want to do before you get started with the calculator. We're going to input these matrices and get the determinant. Go to second matrix to edit. Then we're going to number 1. You can press 1 or it's A, so it's the first one, and enter. We're going to put, it's a 3 by 3 matrix, so 3, enter 3, and each time we put our numbers in, we're going to use enter. This is going to be a little bit different the second time, the second method that I show you. 1, negative 1. Also notice when you press a negative 1, it's not the subtraction sign, but it's the negative inside of the parentheses. Negative 1, 3, 3, 0, 1, 1, 4, 1. And then we make sure you check that and now do second quit. Now second matrix, go over to math and you see DET, which is determinant number 1, press that. And now you're going to do second matrix, go back and enter in the A, just hit enter and close your parentheses, enter again, and the answer is 34. So D is going to be 34. Now we're going to use the new process, another way using the TI-84. It's more of a condensed. So we're going to still go over to math determinant, enter. Now this time we're going to use alpha zoom. You don't have to do the matrix ahead of time. This is going to, and we have a 3 by 3, so we go over now to 3 and 3 and OK. Now when we input our values, we don't hit enter here, we're going to use the arrow. So we have let's just check and do D and see. 1, -1, 3, 3, 0, 1. 1, 4, 1. Now just enter and we get the same answers. So you choose which method you like. I kind of like the second one. Seems shorter. So let's go ahead and do the same thing for the dx, dy, and dz using the last method that I showed you. So we're going to copy that over. Notice you see the red, that was the only thing that changed was the first column. Now we're going to do dy. So we went back to D and we're going to adjust it because A is the same and C is going to be the same. So we just need to change the middle column for D to 2, 2, and 18. Okay, that's 136. Now DZ. Now notice if we go back to D, what changes? The first 2 columns are the same, but the last column is the one that changes. We have 2, 2, and 18. So now we have dx over d, dy over d, and dz over d. So x is equal, y is equal to this one, and z is equal to that one. So dx the x will be 0 over 34, which is equal to 0. And I'm just going to go and put 34 in the denominator because that doesn't change. Our dy value was 136, so that would be equal to 4. And dz value is 68, so that would be 2. So our solution in xyz form would be 0, 4, 2. And again, that says in those three equations at 0, 4, 2 is where they would touch.